Section 1.5. Polygons. A polygon is a closed plane figure formed by 3 or more line segments. It has no curved parts. For example, a triangle is a polygon, but a circle is not. Again, it must be made out of line segments. So that means it can't have any curved parts. There's a line segment, there's a line segment, and there's a line segment. Now, you might have referred to these in the past as shapes, but we have a better definition. It's called a polygon. That's what tells us why this shape is a polygon and this shape is not. The sides of a polygon are just the line segments forming the polygon. Now, more importantly, each side intersects exactly 2 sides, meaning, let's take a look at this triangle. Okay. The red side is intersecting the blue and the green. It's only intersecting 2. The blue side is intersecting the red and the green. It's only intersecting 2. Okay? So, the sides of this triangle are AB, AC, and BC. Now again, the reason why I pointed that out is because what if I added another line somewhere? Like for example, what if I made this picture? Is the entire thing a polygon? No. It's technically a composite figure now made out of 2 separate polygons. But the entire thing itself is no longer a polygon because remember, each side can only touch 2 sides. And we now have this side here, I'm going to highlight green, is intersecting here, the red one. It's intersecting here, the blue one, but it's also intersecting the yellow segment. So, a vertex is the point where 2 sides of a polygon intersect. The plural, meaning more than one, of vertex is vertices. The number of vertices always equals the number of sides of a polygon. So, for example, if a triangle has 3 sides, it also has 3 vertices. A polygon is named by listing the vertices in any order as a continuous path around the outside of the figure. Now, what does that mean, continuous path? Let's say I have this diagram here. I'll call that A, B, C, D, E. You can call that polygon A, B, C, D, E, as long as you're in a continuous path. What you can't do is hop around. You couldn't call it A, D, B, E, C. That's hopping around. As long as you go in one continuous path, you're good. Doesn't matter where you start or where you end. You could call it D, E, A, B, C. So the vertices of this triangle are the points A, B, and C. Now, 2 possible names. Now, we're going to get more into naming triangles later, but there's actually a little triangle symbol. You put that down first, and you list in any order. We could call it ABC. We could call it BAC. It doesn't matter as long as you follow continuous path. ABC, or you could say like BAC. There you go. All right, some important words that we're going to use a lot. Interior. You can think of that as the region that's inside a polygon. So look, this is inside the triangle, so we refer to that as the interior. Now, the exterior is the region that's outside of the polygon. So if I have this triangle, I'm going to try to make it a little bit smaller to match up. Now, the exterior would be anywhere on the outside, anywhere in the yellow out here. This would be the exterior of the triangle. Interior inside, exterior outside. Now, we have convex polygons and we have concave polygons. This is a typo right here. This should say concave. All right, so first is convex. Convex is when here's how to know if something's convex. Do a little experiment. What if I took this side and I extended it? Notice that if you extended that side, it would not go on the inside. It would not go in the interior of the polygon. You can run that experiment with all the other sides. If we extended it, those sides would not go into the interior in here. So all the way around, if you extended all of those lines, none of them would go in the interior of the polygon, which makes it convex. Concave is when you extend the sides, but they do go in. So for example, if you tried that here, oh look, let me extend this. Nah, that doesn't go on the inside, it doesn't go on the interior. But what about this line segment here? If I extended that way, it's good. But now if I extend it this way, it's passing through the interior. Now that's still a polygon, but that's called a concave polygon. You can think of it as the phrase, it's caved in on itself. All right, tell whether the figure is a polygon. If not, explain why. If it is, say whether it's convex or concave. This one is not a polygon. Why? Because this line segment here is intersecting 1, 2, 3 different segments. Now remember, every segment can only intersect 2, but that blue segment is touching the green, the yellow, and the red. We have a segment intersecting more than 2 other segments. Is B a polygon? Sure is. Is it concave or convex? If you extend the sides, none of them go on the interior, so that is a convex polygon. C is a polygon. If you extend this side, it passes through the interior, so that means it is a concave polygon. Now D has a curved part. Can't have curved part. That is not a polygon because it is curved. All right, real quick reminder of some vocab that you've seen earlier before in your academic career. Perimeter of a figure is when you take all the line segments that are forming a figure and you add them up together. You take the lengths of all the sides of a figure and you add them together. That is how you find the perimeter of something. Now the area, these area formulas you have seen before in your academic career, whether you remember them or not. Here's a quick refresher. The area of a rectangle is the base times the height. You also might have heard it as length times width. Means the same thing. The area of a square, yes, it's also base times height, but in a square, all the sides are equal. So instead of doing base times height, you can just square the side. How do you find the area of a square? It's in its name. Its name is a square. You take the side length and you square it. The area of a triangle is 1/2 of its base times its height. Now we're going to define and learn how to identify all these polygons in a later unit that you see here. But for now, let's follow these directions. Use the graph below to find the perimeter and area of the figure. Okay, well, these are horizontal lines, so we don't have to use the distance formula. We are allowed to count them. This has a length of 1, 2, 3, 4. This is 1, 2, 3, 4. Okay, that's 4. This has a length of 1, 2, 3, 4, 5. So that is a rectangle. It's 4 by 5. So that's 5, that's 5, that's 4, that's 4. So the perimeter, you're going to add all the side lengths together. The 4s and the 5s. And the perimeter of that figure is 18 units. Now what about the area? That's a rectangle, so the area is the base times height. So that'll be 4 times 5. So the area is going to be 20 square units. Now, why don't you pause the video and use the formulas in the margin to find the area of each figure below. When you're ready, unpause, and you can check your answer. All right, first, the figure is a square. Well, the area of a square is side squared. So you take the 5 and you square it. So the area of this square will be 25 centimeters squared. And our units for area would be square units. Next is a rectangle. The area of a rectangle is base times height, or length times width. So that'll be 11 times 19, or 19 times 11. It's interchangeable. It really doesn't matter what order you multiply in. So we will get an area of 209 square inches. And the area of this triangle will be 1/2 the base times the height. So 3 times 4 would be 12, and half of 12 would be 6. So the area is 6 square meters. Some more important definitions here. Equilateral is a polygon where all the sides are congruent. So this would show you what a equilateral polygon looks like. It has tick marks on all 4 sides. Equilateral. Equilateral means side. Equal sides. All the sides are congruent. It's equilateral. Equiangular is a polygon where all angles are congruent. Now we'll talk more about that in the next unit. Now, what do equal angle symbols look like? Well, if sides look like tick marks, equal angle symbols look like this. They use arc marks. They'll look for the little swoop. If all the angles have the same number of arc marks, every single angle here has 1 arc mark, that means they're all equal. That's what it means to be equiangular. A regular polygon is both. Now, I do want to stress, just because something's equilateral doesn't mean it has to be equiangular, and vice versa. Clearly, this line segment is a lot longer than this one. It doesn't have to be both equilateral and equiangular, but if it is, that makes it regular. A regular polygon, all the sides are congruent, and all the angles are congruent. It will be in your best interest to memorize as many of these as possible. If a polygon has 3 sides, it is called a triangle. 4 sides is called a quadrilateral. 5 sides is called a pentagon. 6 sides is called a hexagon. 7 sides is called a heptagon. 8 sides is called an octagon. 9 sides is called a nonagon. 10 sides is called a decagon. You think of a decade's 10 years, 10 sides, decagon. 11 is a hendecagon, also referred to as an undecagon sometimes. 12 is a dodecagon. Anything above 12, we just generally use the number and write the word gon. For example, 15 sides we refer to as a 15gon. Yes, there are other names, but we're only going to hold you accountable for up to 12. Make sure that you're identifying important keywords, vocab terms, and etc. when you're reading directions to these problems. So for example 4, it says classify the polygon by the number of its sides. Tell whether it's equilateral, equiangular, regular, or neither. Explain your reasoning. Well, in A, all the sides have 1 tick mark, which means it's equilateral. But all the angles have 1 arc mark, which means it's also equiangular. And remember, when it's equilateral and equiangular, it's a regular figure. We also need to classify it by the number of sides. It's 1, 2, 3, 4, 5, 6, 7, 8 sides. So that is a regular, because it is both equilateral and equiangular, octagon. All right, next one. It's got 1, 2, 3, 4 sides, which means it is a quadrilateral. Is it equilateral? Nope. Not all 4 sides are equal. Look at the angles. 1 mark, 2 marks. Not all the angles are equal, so it's not equiangular. So that is a quadrilateral, but it is neither equilateral, equiangular, nor regular. The head of a bolt is shaped like a regular hexagon. The expressions shown represent the sides of the lengths of the hexagonal bolt. Find the length of one of the sides. Well, in order to do that, I'm going to need to find what x equals, and I'm going to have to plug it in. More importantly, there was something really important here. It doesn't matter that it's a hexagon. That's not what's important. What's important is right here. It said it's regular. If it's regular, that means all the side lengths are equal. That means the 5x minus 1 has to equal the 4x plus 3. And again, why am I allowed to do that and set them equal to each other? Because they said it was a regular hexagon. So let's solve this equation for x. We're going to subtract 4x from both sides. We get x minus 1 equals 3. We can add 1 to both sides. And we get x equals 4. Now be careful. Do we box that in and move on? Nope. It said find the length of a side. Now it doesn't matter what we plug it into. I'm going to plug it in here. So 5x minus 1 means 5 times x, which is 4 minus 1. That'll be 20 minus 1. So the side lengths are going to be 19 millimeters.